What it do, homogeneous money? Ah! All right, in this video, we're going to be talking about 2.6, solving rational inequalities. So you'll see something like this. X minus 1 over 4x plus 3 is greater than 0. We have graphed this. We have done this on our worksheet. So essentially what we're going to be doing is this is saying when this function is greater than 0. So that's that function. So I see that it's greater than 0 from this point on. So from my x-intercept on, it's also greater than 0 this entire time. Remember we were talking about in the y values. But we don't have to have to graph these every single time. So the way that we do this without graphing is, like I said, there's a couple of things we need to think about. These are called our critical values. Critical values are either zeros, x-intercepts, or vertical asymptotes or holes. They are points that we may be changing from positive to negative, so on and so forth. But critical, oh, that's not how you spell critical. That's how you spell cricket. Cricket. Critical values. It'll be okay, you guys. I have two people in here. This is why I feel like a crazy person. I'm talking to somebody, but there's nobody here. But I'm talking to you. You're sitting right there. Anyways, critical values. So in this case, they could be zeros. They could be vertical asymptotes. They could be holes. Don't video record. Well, it's already video recording, so why can't I tell you not to video record when I'm already video recording? This doesn't make sense. Hi-ya! So in this case, we would have zeros when our equation is equal to 0. So we have some zeros when x equals 1. That is one critical value. So if I put in 1, my function will be equal to 0. Our vertical asymptote in this case is when my denominator is equal to 0. So x would be negative 3/4. And we can see that looking at our graph. So 1 and negative 3/4. So we had negative 3/4, we had a vertical asymptote. At 1, we had a 0 or a solution. So what I do from this point, I want to check around those points. So I put a number line down. Negative 3/4 is here. 1 is here. And I am just greater than those values. So I cannot be equal to 0. So that will be open. I'm never equal to a vertical asymptote. So vertical asymptotes will always be open. So we can check around these numbers and see whether we are greater or less than 0 if I plug in a solution. So say I choose like negative 10. If I put negative 10 into our function, we would have negative 10 minus 1 over 4 times negative 10 plus 3. That's a 1. 4 times negative 10. So I would have negative 11 over negative 37, which would come out a positive number. Remember, plus VE and it's my shorthand for positive. So that's all I care about. So in relationship to 0, positive numbers are greater than 0. So I know this is a good interval right here. So I could have anything right there. So it came out positive, my equation is greater than 0, and I want numbers greater than 0. Likewise, we can do the same thing between negative 3/4 and 1. Say we choose 0. If I put 0 into my function, I have 0 minus 1 over 4 times 0 plus 3. 0 over minus 1 is negative 1 over 3. This comes out negative. I do not want anything less than 0. It says my function needs to be greater than 0, so I do not want that interval. Likewise, again, we will choose something outside of 1. So say we choose something like 10. I don't know what I just said, but I said it. We did it. Yay. Words. So plugging in 10 plus 3, 9 over 43. All that I care is that that is a positive number. So that means I can have that interval right there. That is good to go. Yes. All right, so from that point, all we're going to do is write our intervals that are possible. So it looks like we have everything from negative infinity, so all the way to the left, all the way up until negative 3/4. So negative infinity to negative 3/4, where 3/4 is not included. And we have from 1 to infinity. That would be our solution interval. Those are everything for that function to be greater than 0. You probably won't hear me. Or hear you, rather. Ah, they can hear us now, though. All right, so again, same sort of deal, except my function is less than 0. So the numbers that are less than 0 are negative numbers. So when I write my interval and I'm checking around stuff, we're going to be looking for negative numbers. So if you want to help yourself, we are going to be looking for negative solutions. So we want negatives in the end here. Our critical points, our critical values, I still can't spell critical. All right, so the solution would be when the numerator is equal to 0, so we have x equals 0 is possible. We cannot be equal to 4 here. That's our vertical asymptote. We have nothing else to think about. So I can put these on my number line. Numeros, we have 0, and we have 4. Now in this case, 0 is a solution. It's when the whole equation would equal 0. So I can have that value. 4, we'd be dividing by 0, so that is not possible. No es posible. So I need to check around these numbers, and I want negative solutions. So if I pick something less than 0, say negative 10, if I put in negative 10, that's negative 10 over negative 14, comes out a positive. I want negatives, so I do not want that interval. Between 0 and 4, I could choose like 2. 2 over 2 minus 4 is 2 over negative 2, which is negative 1. That is negative, so that looks like that's pretty cool. Cool in the poo, yo. I won't say that. Anyways, 10 over 10 minus 4, which would also be a positive number, so I do not want that. So it looks like my only solution here is between 0 and 4, where 0 is included. So I'll write from 0 to 4, where 0 is included, but 4 is not. All right, look at another. Oh yeah. Oh yeah. So possible solutions. Again, whenever you have a quadratic, go and factor. Make sure you're checking for wholes. Since our function is less than 0, we want negative values. We have solutions. Hey, I spelled it. So we have negative 3, we have 3, and we cannot be equal to negative 1 because that's where my asymptote would be. So now we're just going to have 3 intervals to check around. So we have negative 3, negative 1, and 1. These are all not possible. One, because the vertical asymptote is never possible. The other, because we are just less than 0, so I do not want to be right at 0 for my solutions. All right, so in checking around these values, again, we're looking for negative numbers. So if I choose something outside of negative 3, say negative 5, because that's less than negative 3, I substitute it into my function. If I substitute in here, that's 25 minus 9 over negative 4. All I care is that this is going to come out negative, which is something good. That's what I want. Between negative 3 and negative 1, could choose like negative 2. If I substituted in, I would have 4 minus 9 is negative 5 over negative 2 plus 1 is negative 1. Negative 5 over negative 1 is a positive number. I do not want that interval. Between negative 1 and 1 could be 0. So I would have negative 9 over 1, so that's a negative interval, which is happy day. And then from 1 on, I could choose like 10. 10 squared is 100, minus 9 is 91 over 11. That is a positive. I do not want that. So again, I only want negatives because my function is less than 0. So I'll say everything from negative infinity all the way up till negative 3, and then from negative 1 to 1. That will be my solution interval. Yes. One more. Almost done. Almost done. You guys are doing awesome. I know you're doing awesome. Remember, you can pause the video, rewind the video. Anytime you need to hear me say anything else, I don't remember what I was saying. All right. This one's weird because it's in relationship with 4. But what we can do is we can actually just subtract that 4 to the other side. So we have 2x plus 3 over x minus 1 minus 4 greater than or equal to 0. So now we're in a relationship with 0. So we want all of this to be greater than or equal to 0. So now the other thing that's an issue is that these aren't one fraction altogether like everything else that we've been doing. So it's going to be a little bit harder to work with. But what we can do is, remember, from algebra 2, that's like 4 over 1. And we can get a common denominator by multiplying this fraction x minus 1, x minus 1. So we'd have 2x plus 3 minus 4x times x minus 1 over x minus 1, greater than or equal to 0. Then you can distribute the negative 4 throughout your x minus 1. So you have 2x plus 3 minus 4x plus 4 all over x minus 1 greater than or equal to 0. Keep solving. You want to get this by itself, so we have negative 2x plus 7 over x minus 1 greater than or equal to 0. Hey, we finally got something that we can work with. Oh, yeah. So again, we're going to be looking for, get out of my way. There's our function. All right, so critical values. You can take the denominator or numerator, negative 2x plus 7, wherever that is equal to 0, that would be when x is 7 over 2. So that is one of my critical values. X can also never be 1 because that would be my vertical asymptote. So on our number line, we want positives because our function is greater than 0. I have 1, which it cannot be. I have 7 halves, about 3.5, which it could be because we are greater than or equal to 0 there. So I'm going to test around those numbers. So something smaller than 1 could be 0. Something between 1 and 3.5 could be 2. Something bigger than 3.5 could be 10. So if I put 0 in, I would have 7 over negative 1, so I'd have negative 7, which means I do not want that interval because that interval comes out a negative number. Anywhere you check on here will come out negative, I promise. So if we put in 2, we have negative 2 times 2 is negative 4. So negative 4 plus 7 over 2 minus 1, which is 3. Because negative 4 plus 7 is 3. 2 minus 1 is 1. 3 divided by 1 is 3. So it's a positive number. That's all I really care about. We can have that. If I put in 10, we have negative 20 plus 7 over 10 minus 1. That'll be negative divided by positive, so that will come out negative. So I only have one solution interval here from 1 to 7 halves, where 7 halves is included. All right, hopefully this video has helped you guys out. Promise, I am in my room in the morning, in the afternoon. Anytime you want to come by, I'm here to help. I love you guys. I'll see you later. Bye!